So we're in chapter 8, section 4. I think I said chapter 7 before, so if I did it, I made a mistake, but we're in chapter 8, and we're on the periodic table. We're going to be talking about electron configurations and the periodic table. So this whole section is going to be on configurations of the electrons. It's so amazing that each electron is in its certain level, then each one has a different shell within the level. And then they have how many electrons, and you can figure out how many electrons, you can figure out the shell that it is, and the shape of the shells are all different, and then the level of the shell, the main, the main N group would be the main energy level that it's in. So those three things are important. So the periodic table was originally devised based on similar properties of elements. But the chemists back then in Mendeleev's time did not really understand. They just put them together, but they didn't understand what made them have these properties. Not until later that they realized that the elements in the same group had similar electron configurations that resulted in similar properties. That a lot of their properties had to do with what? With the electrons. And so the electron configurations are very important. And they have a series of orbitals and subscripts for their orbital. So in fact, let me see if I can put this up here really quick. I have a hard time putting these up here. Let's put it up here. Right here, here's one. So if you have one S2 with two S, this first number, the 1 and the 2, would be the energy levels or the orbits. So N, these would be 1 and 2. And then the S's would be a spherical shell inside that orbit. So it would be a subshell, these S's. And then 2 would be how many electrons could fill it up. 1 would be, there would be 1 electron. So 2 electrons in the first shell, electron shell here, and then 1 electron in that shell. That's pretty important as you go. So this is how we're going to configure these together. So it's really not as hard as it seems. When I first looked at this, oh my goodness, But then as you look at this table, it actually tells you, we have hydrogen. It tells you that hydrogen only has the first level, or the first energy level, be energy 1, and it has a spherical subshell there, and it has 1 electron. Helium has the same with 2 electrons in that last shell. So 1s, this is a spherical shell with 2s1. So you have, and they put helium here because basically this looks just like helium. So this will look just like helium, but 2s. It looks like this. And this is helium, so they kind of make it easier. So all these will be helium, which are being 1s2. This is going to be plus that. So you see as you go down, how we go down the line from lithium, and then we're just going down the line here, and you have the next one here, just 1 more electron here, and then you go to, as you go to B here, you'll find that it goes to P, and P has 6 levels: P1, P2, P3, P4, P5, and P6. And these are the dumbbell shaped. Remember, they're different subshells, but they're dumbbell shaped. And you could have, it says basically 2P, this is the second level. This would be the second level of sphere. We've got the first levels are here. Here it actually looks like this. First level, second level of S, now the second level of P. And so these go through here. And each time you get more electrons on this last, all the way down from all of these different, from going all the way down, we have nitrogen, oxygen, fluoride, and it tells all the way going to sodium, and they put these together, abbreviation, and they get more and more complicated as we go here from neon, because this is neon's configuration, which is that noble gas, right? And so it's filled up with 6. And so now they have neon, plus they'll start with 3, and going on the next S and next P. So S's and P's and S's and P's in this whole column. Let's go down more. I think it goes down further than that, or down to calcium actually. So as you see as they went down, basically they're just going first level with the S, second level with a P. So they have a sphere shaped one, and then they have dumbbell shaped ones. And then they go back to the third level with the S and a P. So it's kind of neat because they have, you know, as I said, first of all, they have the energy level, which is 1, 2, 3. Those are the energy levels. That's the level that they're in, kind of their orbital that they're in. And then you have the subshells within there, which are weird shapes. These shapes here, though, are just basically spheres, which are S, and P's, which are dumbbells. Okay, I hope you got that. It's kind of hard to explain. They went and tried to explain this whole thing, but I'm not going to go over the whole thing because basically it was explaining this, which I just did. And so it says the periodic table and subshell filling. So here's the table and how they do that. So you'll see purple are S's. So they have the S block. These mainly have S-looking spherical subshells. Subshell 4p, number of electrons with each shell. You'll see 2, 1, 3. These are the number of electrons in the shells here. So, and they're numbered here with the number of electrons in the shells. And then you'll see on the periodic table, you'll have S, you see 1s, 2s, 3s, these are all S's. You know, they come on this side, all of these are S's. And then these would be the P blocks are over here. So these are the ones that you're mainly going to see combining with each other. And but these P blocks here are going to be 2p, 3p, 4p, 5p, and they're going to go down. And these are the electrons that will be subscripts in each one, the electrons. And so then we have the F block, which is another shape, and you have the D block here. And remember, the D block is kind of like a cross shape, kind of like a cross type shape, and then the F block is more complicated shapes. So these two shapes are actually the basic easy shapes with the main type of the main group of elements. They call them the main group, and then the transition group is going to be D's. They're going to look more like a cross, and then the F block is going to be very complicated. So complicated, and these are all the number of electrons. It says number of electrons within the subshell. So you have 2p, 3p down here. You have 3d, 4d, 5d, 6d, 4f, 5f, and these are going to add to this. You know, go down from here. They just did the basic ones here. So not that you have to know all of these. You can go back to these charts. Okay, what's called valence. So let's see. Knowing the number of valence. What's valence? That's going to be important that you know that. That's, in the outermost shell, you'll have electrons in that atom, and this is important because the valence electrons determine the chemical properties and are generally the electrons involved in chemical bonds. Just remember that. Valence electrons are always involved in chemical bonding. So because if it's not full, if that shell's not full, it will take in more electrons. When they take in more electrons, it will combine with another atom or another ion. The ions will hold together, depending on. So that valence electrons are in that last shell area, that last energy level that says, can we combine with our electrons? Can we give away electrons, or can we take electrons? Or, you know, so valence is pretty important. What the valence of a certain element is. The valence electrons of the main group elements follow a simple pattern containing the groups from left to right, skipping the transition metals. So this gives the number of valence electrons to determine the number without counting. Remember, for the main group elements, the number of valence electrons equals the ones place of the group number. And helium is the exception. Let's go back and look at what are they talking about. So it's right here. So basically, this here, 1 and 2, that's going to be its valence. Valence is over here, are going to be that same over here. So this group and this group are the main group, and so you'll see the valences of all of these. So there will go be 1, 2, 3, 4, 5, 6, 1, 2. Now these are going to be different, even though it says here the number of electrons, they're going to be different because it's a different shape. So therefore the group 1, Li, which is lithium and sodium and potassium, all have 1 valence because they have N and they have S1, 1 valence. See that right there? Where N is the period number, N is the period number. That's going to be that period number. And S is going to be the subshell, and then that little number is going to be the electron configuration, number 1. Similarly, the next group 2 elements, which are calcium, magnesium, and beryllium, they have 2 valence electrons. So basically you take that group NS2, and B and Al, aluminum, those 2, group 13 have 3 valences. So you have NS2, then you have NP1 in the midst of all of this. So they have 3 valence electrons, and O and S group have 6 valence electrons. And so you have these electrons, you have 2 and then 4. So 2 S's and 2 4. So you have 2 S's and 1, that's 3. So you look back over, transition metals generally have 2 valence. So they usually have 2 valence electrons. So let's look back there again. So you look here, you see the valence 1, 2, 1, 2, 3, 4, 5. Those are the valence electrons, and that's how many electrons they're going to have. And they're going to have 2 in the first S, and then so in the first S they'll have 2, and then in the next, if they go into the P here, they're going to have that number in the P that with the number. See, let's go back and show. Let's take, like, I think maybe oxygen's 4, right? So let's go back and see. So in group 16, you have 6 valence electrons, and so you'll have 4 in the last right there, 4 in the last. And that's group O and S. Let's look at group 13, have 3 valence electrons. Okay, group 13. So you're going to have 2 in the first in the S, and then you're going to have a P with 1. So you can have 2 in the first, and then you're going to have, so the carbon electrons are going to be 4 electrons. We're going to have 2, but 2 in the last, 2 in the P. And so this will going on here, and as you go on here, you'll have, this would be 2 in the first, and you have 6 left over in the P. You have 2 in the first, and you have 5 left over in the P. 2, and then 4 left over would be 6 here. So you see how you put 2 in the first S and 2. So that's important. And these, they say, basically have 2 valence in this in these, but we'll see about that. Transition metals generally have 2 valence electrons. So anyway, since elements in the same group have similar valence shell electron configuration, they should also have similar Lewis numbers. Remember those Lewis numbers. All elements in group 16, for example, have 6 valence electrons, and the Lewis symbols would be like that, with the 6 valence around that X, where X represents represents the symbol, right? Okay, let's look. Why are valence electrons important? What are valence electrons? They give all of the chemical bonds, right? Let's get onto section. I was going to look here at your section here. Oh, here it is right here. So basically valence electrons are those that combine with others. They're the electrons that are going to combine with others to hold the atoms into molecules and such, right? The valence electrons give the valence of it. The valence is negative or positive too. So those, how many electrons? So let's give the Lewis numbers. So I'm going to go over these here. Okay, see if I can. Oh, I don't want to go up too far. Okay, here we go. Symbols. So here's iodine. And I looked these up, and you can just look these up on the periodic table, right, where they're at. So in fact, let's go back to the periodic table here first. this table here. And so we have 5, let's see, where is iodide? Right here. Here's iodide right here. It's in number 5, right? So it has 5 valence electrons, right? Really would be 5 and 2 because they have two in the S, but here we have 5. So 5, so you put 1, 2, 3, and then you skip that next one and put 4 over there. Remember how we did these before? So it would have 4 and then have 5. So 1, 2, 3, and we skip this one and put 4 over here, put 5 over here. So here's iodide. So the next one is a transitional, so it's right here, and it says 7 here. As for 7, I did 7, but since it's transitional, transitionals have 2 valence, it said. So I started with the 7 and put the 7 around. I'm like, oh my goodness, it's a transitional. So I put 2 here in this one. And so BE, let's look at where BE is. And it is in the second column right here. And so here we have this column with 2 valence. And so how do we write that? Put a little square with 2 dots, 2 valences. So on to iron, which is in the 6. Fe is iron, and that's 6. Well, it's in a transitional here. So they said transitional usually have 2, right? Well, it said 6, but then 2. So I put down 6 here, but then I'm like, oh, it's transitional. So I changed it to 2. So radium is in this column here, Ra, and it says 2. So I put radium, and it has 2. 3 is here, V, valerium, I think. I'm trying to remember how to pronounce it. But anyway, V, and it has 1, 2, 3. So we put 1, 2, 3. But, oh, yeah, it's transitional, so I changed it to 2. And on to Se, and it's in 4 here, right here, this column, 4. So Se, I put 4, 1, 2, 3, and then put the 4 over here, because we skipped there and put 4 over here, because you always want to make it, they want to even them out. And Sb is in 3, Sb right here in this column with 3. So here we go with Sb, 1, 2, 3 dots. Potassium is easy, it's right here, it's just 1 dot. Then we have oxygen, which is 4, so it's 4 dots, 4 valence ones, 1, 2, 3, 4. And then let's see, Si, where's Si is in, oh, is it Sr? Oh, here it is, Si, it's in 2 valence. So I put 2, Si is 2. So anyway, those are how you do those little things here. So you can read down here, I don't know if you can see all these. Transitional metals, they say, are usually 2 valence, and that's why I changed these transitionals. So that's what I put in the midst of all that. So these are not really that hard. You just know that it looks harder than it is because of all these going, but they basically just get more and more as they add 1 electron, and they only go up to 6 valences here. So, and at least with the P's and the S's. But when you get to the other blocks, the F block and the D block, it gets more complicated. Okay, we're going to stop there because this next video goes on to periodic properties of the elements, and it gets a little bit more complex, but really not. There's just 6 different properties, and I don't think I'll have enough time to go over this whole thing in this one video. So we'll go on to that in the next video.